Hello, this video demonstrates browser-based access to a server-side implementation of EPANET. The server-side implementation is the full EPANET downloaded, installed, and configured on a server, and what we provide here is web browser access to that server. In the demonstration, I'll access the server through a browser, enter the password, and then have access to EPANET running its native GUI. The server itself is an AtomicPi single board computer, not very much RAM, not very much memory. The whole point of that hardware was to test a conjecture because earlier we were unable to get the remote access to work with ARM7. We got EPANET running on an ARM7 Raspberry Pi, and the graphics wouldn't work correctly, and ultimately concluded it was not the application layer, but it was actually the native architecture that made a difference, only for the graphics part. The computation engine doesn't seem to care. Once it's compiled and it runs on whatever architecture you've compiled it for. So for scale up, the key is that if we want to maintain the original GUI that's distributed with the software, we want to build on x86 64s, unless in the future more generic GUI architecture is chosen. I'll create a simple network in EPANET, press the run button, produce results, demonstrate that it works. Upon completion, I'll disconnect, and at the time of the video I've not yet built the file transfer from the client to the server, so uploading files is not currently set up through the web interface. That's pending, so that in the near future a client can access the server, upload an input file, either in ASCII or the .NET binary format, run the model if they wish, or more usefully, edit the content in the GUI, run it, check the edit, save the results, and download them back to their end use. The intended audience is participants in training classes where the implementations would be pre-populated with input files and examples, and the extensive examples could all be pre-placed. So as far as the trainer's concerned, they won't be dealing with multiple file systems on students' different machinery. As far as the student's concerned, everything will be where it's intended for the training, and they can go study and use it later. And as far as long-term maintenance is concerned, the only instance of EPANET is maintained up on the software as a service device. So here goes the demonstration. The demonstration URL is called atomicpi.ddns.net. And it goes to a fairly simple web interface. It looks like this. And the EPANET web services is shown here. If we want to look at the input files, these are the example files that distribute with EPANET. Here's one example that's already been built, that's already up there. We'll demonstrate that in a minute. But to make the remote access, you would select the remote access thing, and what it's doing is it's creating a port 6082, and that's what's going to communicate between this browser window and the remote server. Choose connect. It asks for a password. For this demonstration, the password's DustyCat. Send the password. And yay, we have a window into the remote server. So to run the EPANET instance, we can either choose the menu here, and EPANET is installed in a place called Other. Or we can choose the icon that's left at the bottom of the desktop. I did that on purpose so I'd be able to find it. And the software has loaded on the remote server. We're still in a browser window, and let's first open the example. That's already on the server. It was pre-placed there. We can run it. No big deal. File. Let's create a new one. We'll give this one some silly name. It's called second example. And let's move that here. That's just a text that's appearing on the drawing canvas. And we'll start with a tank. All right, yeah, not much of a network. Okay, there is graphics lag because we're working over the wire. And I'm just putting some values in that will create some sort of results. And I don't really know if that's get a decent amount of head there. Hit run. Run was successful. Let's go ahead and mess with some output. We'll go ahead and have fancy flow arrow, filled flow arrows. Yeah, that's cool. Okay, so demand in gallons per minute, flow in gallons per minute is both color coded and appears adjacent to the object. So there's our supply tank. 65 gallons a minute is going out to our network. So we've successfully simulated that, and let's see if we can generate a time series, links to graph. Okay, that doesn't surprise me that that's not very interesting, since we have a single time instance. But the point is, on ARM7 using a EC2 application layer, that activity we just did would fail. Let's go ahead and save it. And if we save it to Web Clients Projects, which is what I have set up as default, we'll be able to access that later on the web interface. Okay, so we're done. Let's go ahead and exit the program. It's done. We can now exit the connection. Done. And if we go back to our website, we'll see that the second input file is created there, and it's trivial to download this. Right click, download link file. And we actually perform this interface on a Macintosh. The server side is running Ubuntu. It's like a light Ubuntu, light form of Ubuntu. The EPANET application is running in the Wine application layer, which is interpreting the Windows calls in such a way that the Ubuntu operating system can function with them and produce output. And we get the important part is we get the graphical user interface that we're accustomed to. There's no particular reason why you couldn't use a Windows 10 server to accomplish the same task. We selected the Linux base because there's a little bit more granularity of control. That concludes the demonstration of an online implementation, web accessible, of EPANET.